So an example of an entire radical would be like the square root of 57. You have a square root with a number completely inside. An example of another entire radical could be a cube root of 35. Those are examples of entire radicals where the number is entirely inside of the radical. A mixed radical is when there's a number outside, like 3 square root of 5, or 4 cube root of 2. Now what we're going to find is we're going to find that we can change things from entire radicals to mixed radicals and vice versa. For example, one of the things that we learned from before, if I take a number like the square root of 18, 18 is what times what? 9 times 2, 3 times 6, 1 times 18. But of those ones, if I choose 9 and 2, what is the square root of 9? 3. So we can change an entire radical to a mixed radical. So this one here is an entire radical, right? And this one is a mixed radical. And one thing we're going to learn today is that since both of those are equal, what's going to be the simplified one? Because you always have to simplify your answer. When we're going to say that the mixed radical is the one that's simplified. So when you write your final answer, we're going to always try to write our final answers as mixed radicals. Unless the question says, change to an entire radical. You want to see one with cube roots? What could you do with, let's say, cube root of 24? 2 and 12, but are either 2 or 12 perfect cube roots? That's what you have to ask yourself. No. 6 and 4, but are either 6 or 4 perfect cube roots? No. 4 is a perfect square root, but not a perfect cube root. What is the first perfect cube that you know? 2 times 2 times 2 is 8. Does 8 divide 24? Yes. Cube root of 8 times cube root of 3. Almost. And cube root of 8 is 2. And that would be the mixed radical. Yes, you'd be deprived of calculators in this unit as well. Yeah. Sometimes, remember for this, the first quiz in this unit, you're exempted if you do better on the test. So sometimes I do that.
My second quiz, I did really bad.
Okay, we'll see. All right, here we go. So here it is, and this is what I talked about before. To simplify means to reduce an entire radical to a mixed radical. Find a perfect square or a perfect cube. Here, I'll pick another one for you guys to think about. Let's try square root of 75. Can you simplify that one? How about cube root of 54? So this is kind of connected to factoring in that you have to be able to break up the number. 75 is what times what? And then you also want to check, is that number that you're breaking it up with a perfect square or a perfect cube? All right. Square root of 75. What two numbers multiply to be 75? 25 and 3. This is important because 25 you can simplify to 5, and this is simplified.
I just want to ask something.
Cube.
Can I bring like a math song that was made by someone to like be the like
Theme
beginning
song?
of all your videos? Yeah.
Okay, maybe.
It's a parody.
Yeah.
It's called Mama Math.
All right, bring it in.
For a civic math.
Bring it in.
It could be your theme. It could be the theme song.
Does it matter if the 3 and 5 are flipped?
No, but in the end, when you're writing it as a mixed radical, we always write the whole number first.
Okay. So 3 could be outside?
18 times 3 is correct, but neither 18 or 3 are perfect cubes. 9 and 6 makes 15 and 4. 9 is a perfect square, but not a perfect cube. Because these are cube roots, so we have to leave them as cube roots. The square roots actually have a little 2 there, but we never write it to indicate that you need 2 things to multiply to get 75. Cube root is asking for 3 things.
27 and 3.
Close, 27 and 2. What is the cube root of 27? Well, since 3 times 3 times 3 is 27, the cube root of 27 is 3. One thing that can really help you with this is knowing your perfect squares and perfect cubes. So here's a list. Oh, I'll slide it down just a bit. So you need to be able to recognize those. So estimate the square root of 79 without a calculator. Well, you know it's going to be between which two whole numbers?
64, 8 and 9.
It's going to be between 8 and 9 because 8 is the square root of 64 and 9 is the square root of 81.
I got that.
8.9.
So you're thinking it's about 8.9? That seems reasonable. Because square root of 79 would be closer to 81 than it would be to 64. Okay, now we have this key word again, simplify. Simplify is one of the most complicated math words there is. Because we just learned simplify now means something new. For radicals, simplify means write.
Can't they just like make new words for
Well, they could every time say write as a mixed radical. But mathematicians are lazy. Write as a mixed radical is 5 words.
So you have to remember new.
Simplify is 1 word.
But then you have to remember more definitions for that.
You do. Where else have we seen the word simplify? In math. And where have you seen the word simplify in math? Polynomials. If you see simplify with polynomials, it means combine like terms. Where else have you seen simplify in math?
Everywhere.
Fractions. If you see simplify with fractions, it means lowest terms. Okay? Simplify with radicals will mean write as a mixed radical. It'll also mean later combine mixed radicals. It means rationalize the denominator for radicals and a whole bunch of other things that you don't know how to do yet. But we will get there.
Why are mathematicians so Why do they like why do they do this? This makes no sense.
Okay, so these ones we have to write as a mixed radical. So we go to our perfect squares and we see 63. And can you write 63 as two numbers multiplied, where one of them is a perfect square? 7 and 9. And the square root of 9 is 3. Some of you are going to make the following mistake. You're going to be simplifying radicals and you're writing square root after square root after square root that without even knowing it, you're going to just write a square root over the 3. That makes it wrong. So that square root needs to disappear because square root of 9 is just 3, not square root of 3.
I would like to get that. How do you do that with your thing?
Cube roots. Can we write 108 as a cube root of two things? Now, instead of breaking up 108 into all possible factors, this is where this list becomes very helpful. Because you only have to check, does 64, 27, or 8? And 27 works. It's 27 times 27 times 4. And cube root of 27 is 3. What did you say it's called being SMRT? Okay. Fourth roots. Now we have not made, we haven't made a list of perfect fourths yet. So let's figure some out. What would 2 times 2 times 2 times 2 be?
16.
Good. And what would 3 times 3 times 3 times 3 be?
27 times 3 is 108.
80 what?
I guessed 4.
No.
83. 81. 81.
81. Okay. Now, I was watching you guys, and you were doing this. 3 times 3 is 9. How many people got that? No problem. Good. And then you did times 3 and got 27. And then there was this lull, right? When we got to 27 times 3, there was a lull. Okay? Why not do this? What's 3 times 3? It's 9. 9 times 9, 81. Huh? Isn't that cool? Okay. Now, does 16 or 81 divide 128? Which one do you think would work? 16. Now, if I was doing this without my calculator, I'd ask myself, now I need to multiply something by 16 to get 128. I would just look at that last digit. In your times tables for 6, what number multiplied by 6 ends up with an 8 at the end? 6 times 8 is 48, right? So now if I put 8 here, I can check 8 times 10 is 80, 6 times 8 is 48, 80 plus 48 is 128. It's on the video. You can watch it later. Math is awesome. Okay. And then the fourth root of 16 is 2. Fourth root of 8. Yes. Okay. Try these two on your own. Hey. Question for the first one. How many people chose 9 and 8 when they saw 72? Show of hands. How many people did 36 and 2? Okay. So 9 and 8 make 72. 36 and 2 make 72, and both of them have perfect squares. Now, square root of 9 is 3. Square root of 36 is 6. Now, we're going to have to find out, both of those answers are right, which is simpler, which is in the simplest form.
Wouldn't it be 3 and 8?
It will be 6 and 2. And the reason that one is simpler is because we're not done. Because if you look at 8, it's not wrong if you choose 9 and 8 to begin with, because sometimes you see that first. But if you chose 9 and 8, you have to recognize that 8 is 4 times 2. And it still has a perfect square inside. And square root of 4 is 2. And 3 times 2 makes 6, and it works out to be the same thing. So if you see the biggest one first, it makes it easier. But it's not wrong if you started with 9 and 8, you just have to keep going. Sort of like when you reduce fractions, right?
Do you know when the end?
For example, if you were reducing 18 over 12 as a fraction, if you were simplifying that, you might say, oh, I can divide both by 2. And then you get 9 over 6. That is more simple, but it's not completely simplified. You have to divide again by 3 to get 3 over 2. Had you seen from the beginning that you could have divided both of them by 6, it would have been faster, but doing it in smaller steps isn't wrong. Same thing with simplifying radicals. The right side is faster, but it's not wrong to do it a longer way. That would be fine, as long as in the end, the most simplified form is right here, 6 root 2. Now we have the cube root of 32. Can you break that up? 8 and 4. And 8 is a perfect cube, which is 2, and you're left with cube root of 4. Well, this is one of the things that you're going to be tempted to do. You're going to say, you're so used to doing square roots. Square root of 4 is 2, right? But this is a cube root.
So you can't do it that way.
You can't do cube root of 4. It's not on our perfect cubes chart. But you're going to be tempted to do that. Can you see yourself doing that? Just making it 2? Yeah. 2 more.
How are you guys able to get through this stuff so quickly? What do you have, like, what do you have, like, not quite the right back.
48 is 16 times 3. And the 4th root of 16 is 2. You were thinking square root again. 2 times 2 times 2 times 2 is 16. 30. 5 times 6 is 30, but neither are perfect squares. 10 and 3. Neither of them are perfect square.
Dang it.
So what you're going to have to do is you're going to have to go to your list of perfect squares. And if it's 30, it would have to be one of the ones less than 30. Obviously, 25 doesn't work. 25 times 2 makes 50. 16, oh, close, but not quite. 16 times 2 is 32. 9 times, no, it doesn't work to make 30. 4 times, 1 times 30 is the only thing that's possible. So this one is already simplified.
Why do you put tricks like that?
Tricks?
I don't think that's tricks. I think that's just how math works.
Yeah.
Not really. It's not really lying. It's just throwing a curveball at you. With your expectations.
And then sometimes it's helplified. That doesn't make sense. It's helpful to unsimplify. If you combine those words together, you get helplify.
I know what it would mean, but helpful life should be a word.
Yeah, okay, good.
No, it's not, but it should be.
If you help with
Once we put it on YouTube, it will become. Helping someone simplify will just become helplifying.
Or we can put in the description, make up your own definition, and then like whichever one, and then you pick one of the definitions.
So if we want this to be an entire radical, we can't just multiply 7 times 3 because that isn't a rule. But we are allowed to multiply 2 square roots together. But what could I put inside of that first square root so that it's equal to 7? 49. And now your mental math, 49 times 3? 147. So what are some good mental math tricks for doing that?
How do you multiply above?
He's smart. Yeah.
Like, I don't understand.
You could do 3 times 50 and then just take away 3. You should know that. 3 times 50 is 150, and that's 1 too many 3s, so take away 3, you get 147. Or you could do 3 40s is 120, and 3 9s is 27, and 120 and 27 makes 147. All right, the second one.
I hate this more than that.
What you said now makes me suspicious that you're lying to me.
8. Good. 8. And this will become cube root of? 32.
Sorry guys, my math.
Fifth root. Oh my goodness.
Are these like, do we have to go fifth root?
Mm-hmm.
Is it 25?
It's not 25. Not 128. You're looking for 2 times 2 times 2 times 2 times 2.
Oh, 2 times 2 is 4, and 8, and then 16, and then 32.
32.
Yeah. It has to be 32 because it rhymes with woo.
Reliable math.
96.
Wait, are we gonna look over the quizzes? 'Cause
No, I don't want to look at
We're gonna go over our quizzes.
I want to burn.
Okay. Now, we're dealing with square roots, and I said I would show you a place. Okay. I was going to show you a reason why sometimes you would want to unsimplify, why you would want to use entire radicals. Now, first of all, you know that something like the square root of 2 is what kind of number?
A decimal.
It's a decimal, but as a number families, we call it? Yes. So, irrational. If you type it into your calculator, what do you get?
Pardon?
What do you get when you type this in as a
I got it.
1 point what?
One point 414121356.
Okay, good. Now, the square root of 2 is an irrational number. That means it can't be written as a fraction, and you understand that this decimal would go on forever. Okay? I need a volunteer to draw a line segment. Draw a line segment on here with a length of 1. Is that going to be hard? So just ask the rest of the class.
From 0.
From anywhere. You can draw it anywhere on there.
I like this part.
Excellent.
That's
Well,
fine.
we'll get it. There we go.
You know what? You know what?
Perfect. Okay. That was pretty easy, right? We could draw another line segment with length of 1 if we went up, correct?
Guys, 2.
Okay. How long is this?
2.5. Oh, wait, no.
Okay, so a squared plus b squared equals c squared.
1 squared plus 1 squared.
What's c equal to?
1.
No, it's more than 1 because it's longer.
Is it 2? 2? Oh, 1.414, 2.
Right.
Yeah.
Is your mind just a little bit blown because
It's fine.
that green line that we drew is a decimal that goes on forever?
Oh, wow.
That is the line, that is what goes on.
That's a decimal that goes on forever, but its length is as easy to draw as a length of 1. Isn't that weird?
Yes.
Okay. Now, how long is this line from here to here? Let me sit down. How long is that line?
Is it?
We figured out that length is square root of 2.
It's square root of 5.
It is the square root of 5.
Because there's 2 and 1, so 2 times 2 is 4, because you're square root. And then you have to add the 1 square, and then...
Are we gonna be doing something?
Yeah, for sure. This is just grade 9, right? What do we do? This is 1. This is 2. A squared plus b squared equals c squared. You get the square root of 5. Okay. Now, if I go from here to here, that's the square root of 5. If I go from here to here, that's another square root of 5. So this is equal to 2 square roots of 5.
So it's not equal to 10.
It's not equal to 10. This, if I start from here and go to here, that's 1 square root of 2. If I go to the next one, that's 2 square roots of 2. And if I go to the next one, that's 3 square roots of 2.
But it's not 3, it's not 6.
It's not 6, nope. But my question is, which line is longer, the blue line or the green line?
Blue. But no, they're the same. No, it's the blue.
The blue looks longer? Which one's longer? Actually green?
I think the green is longer. No, no.
Are they the same?
I like blue. Secret answer C. It's the orange one.
Figure it out. Do the math, figure it out.
I don't need math.
Non-calculator.
Secret answer C. It's the orange one.
I'm feeling for
That's the
blue.
less obvious one.
I believe in blue. Would it be...
Why is the green one longer?
Square root of 20.
Because 2 root 5 is the same as square root of 20, and 3 root 2 is the same as square root of 18. Yes, the green one is longer. Because if you change them to entire radicals, you can compare them. Oh, hey, here's your homework. Math is awesome.